Hello everyone, welcome to the series AI for Developers, the starting point. Let me give you the recap of our last session. In last session, we learned about the types of machine learning and the process for data cleaning. This was our recap. Let's go walk through quickly. We have discussed the machine learning types and the pipeline for the machine learning model which we built, and then the data cleaning and transformation, where we discuss in detail what is data wrangling and why data cleaning is important, what are the different mediums for data collections, how we do the data inspections, how we deal with the duplicate data, how we perform the cleaning, how to transform it, and what the data binning. This is our recap we have done in our last session. Here is a ML.NET program which you can see, or you're already aware about it. We have ML context as a class for our machine learning model creation, where we create the model because we will prepare the pipeline and then generate a model. And then we load the data in a CSV file. That's a house prices data. After end of the session, I will upload the complete project and the CSV data as well for your practice. You can go through it. It would be definitely helpful for you. So we in iData view, we have loaded our CSV data, and then we perform the data cleaning. That's we only perform the replacing missing values, because as you know, we have to provide the clean data for machine learning model. Otherwise, the prediction would not be accurate. So today we will talk more about data cleaning and transformation. Transforming our data. Let's have a roadmap for today, what we will discuss today. So today we discuss transformers like replacing missing values, drop columns, normalize min-max, one-hot encoding, and at last concatenate of columns. This is our agenda for today. We will discuss with these topics. Let's start a practical guide. So here we loaded our data, and let's run this. And this was our first stage. We replaced the values. You can see in the CSV file. In the CSV file, if any values is nan, we are now considering a numerical values. Here you can see the one value, the price value, I make it null, and we have to deal with the null values, and because we don't proceed with the null values, so the data must be cleaned before we proceed with machine learning model or the machine learning models training. Here you can see the transformers, and then there is one method is replacing a value. How we like to replace the null values? So there are different modes. You can choose the modes as you like, and which is best fit for your data. So that's your choice completely. I picked up mean, so that means wherever the null values found in the price column, it would be replaced by the mean data, mean. So here I can make this column. Let's say this is the output column, this is the input column, and we have to define what is input and what output column you like to generate. I says out. Let's do this and try to run it. Okay, so let's say you can see price, and here we can see the nan value is shown here, but the price out, this will the nan value is replaced by the mean value of this price data. So this is the replacing values, and here we can have flexibility as well. I provided the input and output both columns, but you can leverage with this. Let me show to you. And the other thing is, if you have more than one column, or definitely you have multiple columns in your CSV, then how you can work with that. So let me show you what you can do here. You can create the array, and then here we have input output column pair, where you can define your input and output, but you can define only input column, and then output column would be the similar. So let's say I have price, maybe I can define the new this one column, and then another column I can define from our CSV. Let's say, okay, the bedrooms. Here we can say the another column is called bedrooms, and then once you define all the collection of your columns, you can choose the mode, replacement mode, from which you like to replace the null values. Okay, let's say I have done with the two columns, bedrooms and price. Let's have a look. So you can see over here, you have price and two price columns. So that's very clear. One is the output column and one is your original columns. Similarly, you can see with the bedrooms, we have bedroom and bedroom. Yeah. If you are confused, you have any confusion, you can define your output column. Let's say out, and then your input column price. Similarly, you can do for this. It's completely up to you how you want to. Okay. So you can see. You can see here you have bedroom out, price out. These columns are available here. All right, now other transformers, let's have a look. This is replacing value. Now we have to define the normalize, or use the normalized transformer. Why we use the normalized transformer? That is really important, and you need to understand what is the normalized transformer. So here you can perform the feature scaling. So let's see how to perform this. You can add dot append ml context dot transformer dot normalize min-max. What is normalized min-max? This is feature scaling. Feature scaling is a technique used in machine learning and data pre-processing to standardize or normalize the range of independent variable or features of dataset. So basically, this min-max scaling transform data to a specific range, typically between 0 and 1, preserving the relative difference between values. This normalization technique is ideal for dataset with known bound, ensuring that all values are rescaled proportionally to fit within the specific range. Why this is required? This is important for you to understand the difference. Where you can see in our CSV here, you can see, let me open this CSV. Just a minute. Okay, open this CSV so you can have a look here. Here you can see we have numerical data, but some of numerical, you can see the price, some prices are too higher, some prices are too lower. So we need to convert these price into proportional, or similarly the square feet area of the house or flat, and then square feet of living. This data, you can see there are some variations in the data. So we will convert, or we will normalize this data using min-max feature scaling technique, and then data will be convert it into a range. Most preferably the range is between 0 to 1. Okay, so let's continue with this. Here as similar with our replace missing values. If you want to normalize or if you want to scale one column, then you can do in this way. Let's say price is scaled is output column, and then price. Okay. So you can see another column is price scale. Let's run this. Now you can see the price scale. This is converted in the range of 0 to 1. Proportionally, it will be converted. Similarly, you can do this for more than one columns. As we have seen earlier, here you can write collection, new input output column pair. We can add new input output column. Let's say the bedroom. We can say bedroom is scaled. Bedroom. Okay. Let's have a look. You can see the bedroom scale is another column is added over here with the range of between 0 to 1, right? So in this way you can add more columns, or you can scale your more columns as you want. Another transformer we will discuss, one-hot encoding. What is one-hot encoding? This is pretty important to learn why one-hot encoding is required. As you can see in our CSV data, as you can see over here, the machine learning model needs the numeric data, but if we have categorical data, then this categorical data needs to be converted, and to convert that categorical data we have one-hot encoding. Let's say if we can talk about this facing. So we have 4 facing: north, east, west, and this string data we will not proceed for our model training. So this data we will convert into one-hot encoding. That is, you can understand as a enums in your C#. Yeah, so it will be converted in a enums. Let's have a look how this conversion will work. Okay, let's add one more transformer here, ml context dot transform dot one dot categorical, because this is the categorical one-hot encoding. Categorical and one-hot encoding. Here we can define our one-hot output column. Let's say facing, encoded, and then input column facing. Okay, one is missing. Fine. So this facing column will be encoded, and you can see facing encoded. Initially it was north, south, east, west. Here you can say sparse of vectors. If you are from mathematics background, then you know what is sparse vector. A sparse vector is a representation where most values are 0. It is often stored as a key value pair, making it more interpretable and resource efficient compared to dense vectors. Do you know what is difference between sparse and dense vector? If you don't know, let's have a look. Let's see over here, two types of encoding is sparse and dense. In sparse, we have most values are 0. Yeah, so this is done for our encoding where we done the facing, yeah, encoding. And the dense, we have less zeros values. This is the representation in the vector. Okay, once we perform the one-hot encoding. This means all the categorical columns would be encoded. That's a demand for machine learning. We have to make our representation in a numerical form. And now once you have done these things, and probably you can remove the columns if you like. Then let's say append, and we can remove the columns if we want it. We don't want to include those columns. For example, the bedroom, that we can remove. For price, we can remove here. So let's do this. But before doing this, we can mark as this like out, because otherwise you would be confused what is input column and what is output column. We can say price, and we can say drop columns. So we can drop columns, as you can see over here. Let's say price, I can drop. I can also drop bedrooms. I can also drop facing. Okay, what's the problem? Missing. Let's look here. Great. Here you can see price columns, bedroom, facing, these all are removed. Now you can see price out, bedroom out, price scale, bedroom scale, facing encoded. Yeah, these columns you can see over here. Good. The last topic for our today's session is concatenation. Now we will concatenate the columns which we have added. This is the preparation for our next model training. In the next session, I will teach you how to go with the regression model and how to train a model with the data. Let's have append ml context dot transformer dot concatenate. Here we can see features, and then the input column pairs, which through which column we like concatenation. So we know we have some columns. Let's say price out. This I like to proceed for our model training. Here we can include these columns. Those we already perform the feature scaling. We already perform the replacing and matching values. We perform the one-hot encoding. Those we can treat for our concatenation. Yeah, you can look into this. So then this new column features would be added in our data. So you can say the features column added in our data, and that's definitely dense vector. As you have seen earlier, we have more zeros in our matrix, then it is become sparse. If we don't have more zeros, it would be treated as dense vectors. Yeah. So thank you guys. This is the session for today that we planned in the beginning. That was agenda. We have learned the replacing missing values in one or more than one columns, dropping a columns. We have learned normalization, feature scaling, which is called min-max. One-hot encoding. That one-hot encoding we will perform on the categorical columns. Where you have a categorical columns, you need to perform one-hot encoding. So this is the only for the training purpose. When you continue work with your actual machine learning, for the machine learning model, when you start your working, you need to taking care of each and every columns. So because for the model we have to provide the numerical values in each columns. If you have a data which is not used, or you feel that data is not necessary for the model training, simply remove that column from your data. Here in this you can see we have several columns: city, locality, bedrooms, bathroom. We can decide which column or what data is not important for model training, because going forward I will utilize this for predicting house price based on the various parameters, which you can see in the next session. So I will upload this into this session in this YouTube video. You can download this program and do your practice. Thank you very much. Have a nice day. Have a nice evening. Thank you.